for 2 seconds. All right. So after you define the scissors, paper, rock game, we see that this is now a perfectly perfect game that makes sense, right? Because if we put in 3 numbers, we can potentially put in 3 numbers. Okay, we can put in number equals 1, number equals 2, or number equals 3. And if it's equal to 1, then it's going to be a draw. Number equals 2, then we win. Number equals 3, then we lose. Okay, so that makes it so that we're going to make a random game of scissors, paper, rock. Because when we're playing against the computer, we don't need to see exactly what the computer is using. Sometimes they might use scissors, sometimes paper, sometimes rock, right? But the outcome of the game doesn't change in that it's always a 3-in-1 chance. When you are playing scissors, paper, rock with someone, if they were perfectly random, then it's going to be a third of a chance to be a win, a third of a chance to be a draw, and a third of a chance to lose. Okay, whereas when we were playing heads or tails, it's a 50-50 chance. It's either head or tails. It's either win or lose. But for this one, we are going to win or draw or lose. And last time we didn't use my blocks, but we're using my blocks this time. But after a while, you'll realize that when you play scissors, paper, rock with a real person, humans are not like robots. Humans have a pattern, right? Sometimes they're not completely random when they're choosing scissors, paper, rock. For example, I have a little daughter. She'll always do paper when she plays the first game. And then we know that, so that now if I know the pattern, then I will win some more. Okay, but in this game, it's not going to be like that. This game is going to be completely random. Okay, but in the future, you might be able to learn the pattern of the person who's playing scissors, paper, rock, so that you can see, you're playing paper a lot more than scissors. Then the computer can try to use that and exploit that against you. And that's what machine learning does. That's what artificial intelligence does. We can exploit the person's pattern. But today's game is not going to be like that. Today's game, we're going to make a random game where you have a third of a chance to win, to lose, and to have a draw. And then it's got SPR because this is the game, right? We drag in SPR. And then instead of plugging a number in here, we plug in a random number between 1 and 3. So we go into operators and then pick random 1 to 3. 1 to 3. And then we plug that into here. And then that is your scissors, paper, rock game. So let me test it out. So I'll just leave it on the screen so that everyone can have a look. But then I'm just going to let's play scissors, paper, rock. It's going to ask me scissors, paper, rock, paper. Oh, I lose. And then you can press the flag again to play again. Scissors, paper, rock. I don't want to play. And then she says, let's play another time. See? So if I press flag again, play scissors, paper, rock. Rock. You win. All right. So now it is completely randomized because we're not giving the player a choice to pick number 2. Because if they pick number 2, then they always win. If they pick number 1, that's always a draw. If they pick 3, it's always they always lose. So that's why we put in a randomizer, but we only check if they put in a correct answer for scissors, paper, rock. So if they put in scissors or paper or rock, then they can play the randomizer. If they don't, then we play next time.